Well, we're going to talk about the redshift. And if I get my pen going here, let's see. We're going to talk about the redshift. As it pertains to astronomy and cosmology. Let's say, for instance, we have, well, let's say you are here, and here you are again. And let's say, for instance, we've got a star that's out in here. So this is some star, and let's do it again here also. We've got a star. So these are both, they could be stars, they could be galaxies. And so they're emitting light. And we know light travels at a constant rate through a vacuum. And we know the speed of light is 3 times 10 to the 8th meters per second. So let's say this one is stationary, this star. Let's see if I can spell it right. Stationary. And let's say this star is moving away at 1/2 the speed of light. 1/2 the speed of light. Oh, come on, write for me. 1/2 the speed of light. Yes, came right here. There we go. Well, as we know, light is a transverse wave, so it's going to send out transverse waves. And let's just say we want to draw this one here. And I guess we'll pick this color. This one's fine. So let's just say we got, and let's do a half here and a half here. So let's say we've got this wave, this light from this star, and it's traveling out. And it's coming to us at a certain wavelength and a certain frequency. So we know frequency is the number of crests that pass a given point per second. So this stationary star is sending out, let's just say it's sending out a green light here. And we can probably get one more in here. Let's see if we can do this from the star. There we go. Well, let's say this star here is also sending out light, but it's also moving away. And as we talked about in the Doppler effect, what you're going to find is that it's actually going to, so let's say we're here. Let's see if we can go back to our color. Let's say we're here. But now this star has moved out here. And it moves at 1/2 the speed of light. Well, it's still going to send, its light is still going to travel at the speed of light, but what's going to happen, it's going to stretch out. So see, we got 1, 2, we got 3 crests here. So we're going to have to see if we can get this stretched out a little bit. 1, let's see, we get 2, we get 3 here. And we need to put a mark in here, 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 and here. So we've got 3 crests. But now what's happening is that they're being, oops, not very good on me here, but they're actually being stretched out where the wavelength is getting longer. The light's still traveling at the speed of light, but the wavelength is getting longer. And again, we know a wavelength goes from here to here. That's wavelength. Well, you can see on these, and again, my drawing isn't real good, but this wavelength is getting longer. Well, if wavelength gets longer, we know the frequency will also get lower. So let's see if we can look at that in a little bit better detail here. Let's draw our person again. Got our person out here. And let's say what ends up happening is, if we look at the Roy G. Biv, and we got Roy G. Biv, red, orange, yellow, green, blue, indigo, violet. If the frequency is decreasing, so frequency is decreasing, we know wavelength is increasing. It's going to look like this green light, and that's what we started with. We started with this green light. It's going to get shifted to the red side, and that's called a red shift. So when we look at this, it looks like this green light looks redder. So the green light looks redder. If you're, let's see, it looks redder. If you remember the, we talked about the Doppler shift when we talked about sound, and we have a sound here. Let's say whoops, okay. We got to turn that layer on. If we have, you are here, and we talked about a car standing or moving out here somewhere, and it's driving away in this direction, we know it's actually moving away or outrunning its own sound wave and catching up to its own sound wave here. So we know here that the frequency is decreasing while the wavelength is increasing. And we know that as a Doppler effect. And we saw that as a decrease in pitch. So we had for sound, it's a decrease in pitch, or a lower pitch, if you will. For light, the decrease in frequency is going to be shifted to the red side. So for light, a decrease in frequency, the light shifted to the red. Shifted to red. Oops. Should be a D in here. Shifted to the red. So it's actually going to the red side. So when things are moving away, such as stars or galaxies, their light is shifted to the red side. And that's the whole idea of an expanding universe. Expanding universe. Likewise, if the universe was contracting, it would be shifted to the blue side, or you'd find the wavelengths are shortening, therefore the frequency's going up. So you look at this. Also, the con one's not too bad, so you can take a look at that one also. And again, as usual, if you've got any questions, feel free to ask in class. But the big thing to remember here is, the redshift is evidence for an expanding universe where the objects are moving away. And we looked at the Big Bang Theory before, and we saw, we looked at the balloon where all things are moving away from each other. So that'll be it for this one.